Our report is about to construct, deliver, and maintain systems project. So basically, this chapter covers the 3 final phases of the system development life cycle, or the SDLC. So first, we examine the different activities that are involved in in-house development. Organizations usually acquire information systems in 2 ways. So first, they develop customized systems in-house through formal systems development activities. And next, they purchase commercial systems from software vendors. These 2 ways of acquiring information systems have their own advantages and disadvantages. However, they are not mutually exclusive option. Some firms purchase commercial information systems to satisfy their information needs, while others, to satisfy their information needs, they develop the systems through in-house. However, in SDLC, it is not always a success story. Historically, there are 3 problems that account for the system failures of the SDLC. So first, we have the poorly specified system requirements. SDLC is not a precise science. It involves human communication and exchange of information between users and professionals. And this exchange of information is imperfect. Mistakes can happen in identifying the problems and needs. Because of this uncertainty, SDLC tends to be not a smooth linear process, because in reality, SDLC is a cyclical or iterative process. For example, systems designers may go back to the analysis stage from construct stage to gather additional information in case the problem in systems development change. So, this cyclical process of the SDLC may result to a time-consuming and repetitive work of systems development that may eventually result to a poorly designed SDLC. The next problem is ineffective development techniques. The problems that are being cited in the poorly specified systems requirements are amplified by ineffective techniques for presenting, documenting, and modifying the system's development. So, the use of the computer-based graphic software that permits the original design and changes to be made electronically considerably improves the situation. Next problem is the lack of user involvement. The major cause of systems failures are the lack of user involvement during the critical stages of the system's development. Too often, this happens when the system's design reflects the perception of the analysts of the information needs rather than the perception of the accountants or the end users. These problems have led the researchers to seek ways to improve the development process. The efforts have focused on reducing the development time, facilitate transfer of information, encourage users' involvement, and improve the overall system development. So, there are several widely used techniques for improving the system's development. First, we have the prototyping. Prototyping is a technique for providing users a preliminary working version of the system. So these are built quickly and inexpensively with the intention that it will be modified. Hence, prototyping is an effective way to establish users' needs. Is the case approach. or the computer-aided software engineering. It is a technology that involves the use of a computer system to build computer systems. Case tools are commercial product softwares consisting of highly integrated applications that support a wide range of activities of SDLC. So this methodology was developed to increase the productivity of systems designers, to improve also the systems development cycle, and to expedite the SDLC. Next is the PERT chart. The project evaluation and review technique is a tool for showing the relationship among the key activities that constitute the construct and delivery process. So this tool involves the features of activities, events, paths, and critical paths. Activities are the tasks to be completed in a project. Events mark the completion of one activity and the beginning of the next. Paths, it routes the diagram that connect the events from the first to the last. And the critical path, this is the path with the greatest overall time. So here's an example of the PERT chart. And for our last tool, we have the Gantt chart. The Gantt chart is a horizontal bar chart that presents time on a horizontal plane and activities on a vertical plane. So the bar marking the beginning and ending dates are the time associated for each activity. This Gantt chart actually is highly popular because it can show the current status of the project at a glance. In in-house development activities, it falls conceptually into two categories, which are construct the system and deliver the system. In construct the system, its goal is to design and build softwares that are ready to be tested and distributed to its user community. So this phase involves modeling the system, programming the applications, and application testing. In designing and programming of modern systems, it follows one of two basic approaches, which are the structured approach and the object-oriented approach. The structured design approach is a disciplined way of designing systems from the top down. Actually, this starts from depicting the big picture of the proposed system that is gradually decomposed into more and more detail until it is fully understood. And this approach actually is being documented by data flow and structure diagrams. Okay. And next we have the object-oriented design approach. This approach is to build information systems from reusable standard components or objects. A good example of this would be the car manufacturers. Car manufacturers don't create new models of cars from scratch. These new models are being created from the standard components that they already have. So, reusability is central to this approach. And consequently, this approach can reduce time, reduce the cost to the development, the maintenance, and the testing, and improve the user support and flexibility in the development process. The elements of the object-oriented approach are the objects, classes and instances, and inheritance. So first we have the objects. Objects are equivalent to nouns in the English language. For example, we have customers, vendors, inventories, accounts, and other objects that are involved in the system. And these objects have two characteristics. They have the attributes and the methods. The attributes are the data that describe the objects, and the methods, these are the actions that are performed on or by objects that we change their attributes. Okay, next element is the classes and instances. An object class is a logical grouping of individual objects that share the same attributes and methods, while an instance is a single occurrence of an object within a class. The last element is the inheritance. Inheritance means that each object instance inherits the attributes and methods of the class to which it belongs. The purpose of the system design actually is to produce a detailed description of the proposed system that both satisfies the system requirements identified during system analysis and is in accordance with the conceptual design. So in this phase, the system components such as the databases, the processes, and the controls are meticulously specified. So these completed plans are being forwarded to the final phase of the SDLC, which is the system implementation, in which the system is being physically constructed. The systems design phase of the SDLC follows a logical sequence of events. We have create a model, data model of the business process, define conceptual user views, design the normalized database tables, design the physical user views, develop the process modules, specify the system controls, and perform a system walkthrough. The first phase of SDLC is data modeling. So this is the task of formalizing the data requirements of the business process as a conceptual model. The documentation instrument being used for this data modeling is the entity relationship diagram. Next phase is the design physical user views. In designing physical user views, the designing of output is being considered. Output is being defined as the information the system produces to support user tasks and decisions. So, output must have certain attributes in order to be useful in a system. So, these are the output attributes. We have the relevance, summarization, exception orientation, timeliness, accuracy, completeness, conciseness, and output reporting techniques. That's all. Thank you. Okay. Stop no. Our report is about construct, deliver, and maintain systems project.
Yun lang. Yun lang.